right, so in this set of notes, we're going to be looking at how quadratic equations can be used with circles. There are no new theorems or definitions that we need to talk about in this case because ultimately these are the same theorems you've already been introduced to. It's just simply a matter of when you set up the equation using those theorems that the quadratic presents itself. So in this case, let's look at the first one. With this in mind, I see a tangent segment and a secant segment. Now, whether you recall or not is another story, but a tangent segment always, its length gets squared. Whereas for a secant segment, we take the length of the secant and multiply it by the external portion. So in this case, the tangent squared becomes x squared. And for the secant, we get the whole length, 20, times the external portion, 4. So in this case, we get x squared equals 80. A nice simple quadratic to solve. To get x by itself, we take the square root of both sides, and x becomes the square root of 80. Now, for all intents and purposes here, we could simplify that if we were asked to, or if the problem asked for a decimal version, then we could go to the calculator and determine what that is. For now, I'm more worried about whether you can solve the equation correctly, rather than when you can type it into your calculator to get the decimal version, or whether you can simplify it correctly. So in this case, I'm going to leave it as the square root of 80. All right, so let's look at the second example then. Same type of relationship that we see in the first. The tangent gets squared, and for the secant, we take the length of the entire segment times the external portion. So the entire segment here would become x plus 15. So in terms of our equation, we take the whole segment, x plus 15, times the external part, x, equals the tangent squared. So 18 squared. All right, with all quadratics, we're going to go ahead and distribute this left side. So x times x gives me x squared, plus 15 times x equals 18 squared, which is 324. As we've discussed before, to solve a quadratic, you want to set it equal to 0, and we want it in descending order. So this is already in descending order. To get it equal to 0 means subtracting 324 from both sides. And since that's the constant, we'll put it on the right side of that x term, like so. Once you have it set equal to 0, you want to look for a common factor. In this case, the only common factor we'd have is a 1, so there's nothing to factor out. Then we go to factoring into a binomial if possible. Now, sometimes it won't be possible, as we've seen, but in this case, let's see, x times x will give us our lead term of x squared. Now I need two factors that, when multiplied, give me 324, negative 324 to be exact. Now that negative is important because it tells us one of these is going to be positive and the other one's going to be negative. So I'm looking for two numbers that have a product of 324 and a difference of 15. So let's see, 324 is 27 times 12. And you could hunt and peck for that one for a while, but I'm going to just tell you that it's 27 and 12 for the sake of time. So positive for the 27, minus for the 12, and I know that's the direction it's going to have to take in order for this middle term to be a positive 15. The larger number has to be positive. All right, so now we have a product of two values, x plus 27 and x minus 12, that is 0, which means the only way a product can equal 0 is if one term or both equal 0. So in this case, either x plus 27 equals 0 or x minus 12 equals 0. Those are the two different ways that we can produce a product of 0, as if one of them is 0. So here, x equals negative 27. Or in this case, when we add 12 to both sides, x equals 12. So while these both are solutions to our quadratic. Only one of them makes sense within the problem. Since we're talking about the length of a segment, lengths must be positive, which indicates that the only value that will work in the context of this problem is x equals 12. We can't have a segment length that's negative, so the negative 27 would not be productive. Now, if we go back and check our work, then here we'd have 12. The 12 plus 15 would produce a 27, and 27 times 12 does equal 18 squared. All right, moving on to example 3. A different situation in this case. Remember, with two intersecting chords, that the product of the two parts of one chord must be equal to the product of the two parts of the other chord. So in this case, multiplying the two parts of this chord together would mean multiplying 4x by the quantity 2x plus 2. That must be equal to the product of the two parts of the other chord, 16 times 21. And we're going to follow the same process that we have before. Start by distributing the right side, or this left side. 4x times 2x gives us 8x squared. 4x times 2 is 8x. On the right side, 16 times 21 gives us a value of 336. All right, so to solve our quadratic, we need to set it equal to 0, which means subtracting 336 on both sides. I'm going to leave this side in descending order. Minus 336 equals 0 on the right. Once we have it set equal to 0, we look for a common factor. So let's see, these are both divisible by 8. Is 336 divisible by 8? Yes, sirree, it is, 42 times. So I'm going to go ahead and factor that 8 out. And remember, the only advantage that factoring this value out has is that it gives us some smaller numbers to work with. All right, so in this case, the 8 is simply a factor. There's no variable out there, so I'm going to divide both sides by 8, and that's going to leave me with x squared plus x minus 42 on this side when I divide by 8. And here, 0 divided by 8 is 0. All right, now let's deal with the factoring portion. So we have a trinomial that we hope will factor into two binomials. So in order for the first term to have a value of x squared, then the first term of both binomials must be x. Looking at the last term is negative. So the product of these two numbers must be a negative, means that one of them must be positive, the other must be negative. So I need two values that have a product of 42, but whose difference is 1 for the 1x. And that would be our 7 and 6. Since this middle term is a positive, the higher number 7 needs to be a plus, and the 6 needs to go with the minus. Once we have it factored into the two binomials, we have two values that have a product of 0. That means either the first term equals 0 or the second factor equals 0. Here, in this case, the only way that quantity can equal 0 is if x equals negative 7. We get that by subtracting 7 on both sides. And in this case, we add 6 to both sides to get x equals 6. Okay, so here again, we have two solutions, but we need to make sure that within the context of the problem, which one's going to work. If I were to take a negative 7 and substitute it here in place of x, then this length would become negative 28, which does not make sense in terms of length. Whereas if I use a 6, I get a length of 24, which does make sense. So the x equals 6 would be our choice in this case. All right, so at this point, I would advise you to pause the video and attempt number 4, and then once you've done so, come back and check yourself. All right, so assuming that you've taken the time to work it out, I'm going to work through this one a little bit more quickly. All right, we have two secant segments. The secant, we take the entire length times the outside part. So here, x plus x minus 2, x plus x minus 2 gives us a length of 2x minus 2 for the whole. So the whole, 2x minus 2, times the outside part, x, equals. Now we'll do the same thing for the other segment. The whole, in this case, 5 plus 7 is 12. times the external, part 5. All right, distribute on the left, we get 2x squared minus 2x. Multiply on the right to get 60. Set it equal to 0 by subtracting 60 from both sides. Look for a common factor. If there is one, factor it out, and then divide both sides by it. In this case, everything's divisible by 2, so we factor out the 2. Divide both sides by 2 to get rid of that factor, just to simplify our process and nothing else. Keep in mind, if there were a variable here, we could not divide by the variable on both sides. All right, factor into two binomials. For the first term to be x squared, both first terms must be x. For the final term to be a negative 30, one term must be positive, the other negative. And their, product of 30 and a difference of negative 1, so 6 and 5. 6 is going to have to go with the minus in order for that middle term to be minus. And we can check that. Negative 6 plus 5 is negative 1. Okay, so separate into two equations, x plus 5 equals 0 or x minus 6 equals 0, and solve each equation. So in this case, x equals negative 5, or adding 6, in this case, x equals 6. There again, the negative length does not make sense in the sense that x is a length, so x equals 6 becomes the solution. For further examples or practice problems of this type, see your teacher.